Okay, I am here in my kitchen because I'm going to be real honest. What we're about to do, it's going to look like a can of alphabet soup got spilled all over your packet. But don't fret, as long as we stick with those algebraic properties that we've been practicing and reminding you of on every equation we've solved, this is going to be no different from solving any other equation. You're not going to believe me, but I promise you, if you follow the steps that we've been practicing with solving other equations, this is going to be exactly the same thing. Okay, let's get to it. Literal equations. If there is a lesson in Unit 2A that's going to slow you down, it's probably going to be this one. But I promise you guys, pinky promise, that if you show your work, you take your time, and you do what I tell you to do, this does not have to be any more difficult than solving any other equation. If anything, it should be easier because you won't have to worry about sign errors as much, and you won't have to worry about rounding numbers to the right answer because everything's a variable, okay? Or most everything. So our learning target this time is given an equation in two or more variables, I can solve for a specified variable. All that means is basically we're going to give you a formula. Some of them may not be formulas, but most of the time it's going to be some sort of formula, like the formula for perimeter or area or something like that. So it's going to have a bunch of different variables in it, and we're going to ask you to solve for a given variable. So if I give you perimeter, solve for the length. If I give you area, solve for the width, something like that. That's all this is going to be. All right, so let's look just a tiny bit of notes. Literal equations are equations with two or more variables. Think of that literal as literary. It's got a bunch of letters in it. But they're still just equations, but they do have a bunch of variables in it. Sometimes when we're given formulas, it's helpful, especially in science class or situations like that where you're actually trying to utilize some of these formulas. It's helpful to highlight a specific variable, and it's easier to see the specific variable if you isolate it using the different techniques we've done when solving other equations. So to solve a literal equation for a given variable, we use the exact same methods as when we solve our traditional equations. That should say traditional, sorry about that. We have to use our inverse operations, which is what we do every time. So I'm going to do two examples for you. The first one, and I'll go ahead and tell you, this is our favorite one. It shows up all over the place. The formula for the perimeter of rectangle is perimeter equals 2 times length plus 2 times W, which makes sense, right? If I've got a rectangle and here's my length, and here's my length, and here's my width, and my width. If I add all that up, which is what perimeter is, then I end up with 2 L's plus 2 W's. That's where that formula comes from. Now what they want us to do is solve for W. What that means is I'm going to rearrange this formula until W is all by itself. Now, if this had been something like P equals 21 plus 2W, then what would you have done? You would have immediately said, I got to subtract off this constant. It's the thing farthest away from my W. I'm going to move it away. I'm going to do the exact same thing here. I'm going to subtract 2L from both sides of my equation. Now, that's not a straight line, but when I do that, on this side, just like always, subtracting 2L from 2L makes it 0, and 0 plus 2W is just 2W. That's just your additive inverse and your additive identity working together to get rid of that term. Over here, things are a little bit different because remember, in order to be able to add or subtract terms, they have to be like terms. They have to have the same variable and the same exponent. Well, this has a P and that has an L. Those are not like terms, and therefore I can't actually do this subtraction. The best I can do is rewrite it. Perimeter minus 2 times the length. That's all I know. Okay, now I'm going to come over here. My W is still not by itself, but I see that what's happening to my W is I'm multiplying by 2. If I want to undo that, then I'm going to divide by 2. Because of my division property of equality, if I divide by 2 on this side, then I'm going to divide by 2 on this side. That cancels and leaves me with just my width. Yay! That's what I wanted. Over here, Again, I can't actually do that division because p divided by 2, I have no idea what that is because I don't know what p is. I can't actually do this division because I don't know what L is, and I can't, there's nothing else I can do. So my answer is p minus 2L over 2. The end. That's it. So that wasn't so hard. It was barely like math, a little bit like alphabet soup. All right, so let's look down at one more example for you. The formula for circumference is c, which is circumference, equals 2 times pi times the radius, which we use r. In this case, we want to solve for r. So I'm going to start the exact same way. I'm going to rewrite my formula, c equals 2 pi r. My goal is to get r by itself. Well, what's being done every time I'm inspecting? What's being done to this r first? What's being done is it's being multiplied by 2 and it's being multiplied by pi. Well, if I want to undo multiplication, I'm going to use division. If I divide on this side, I've got to divide on the other side as well because of that division property of equality. I need to divide by both 2 and pi. You can do that at the exact same time. There's nothing wrong with that because those 2's are going to cancel or become 1. Pi divided by pi also equals 1. Both of that is because of my multiplicative identity. My multiplicative inverse. And then 1 times n, there's my identity. That's just not in r. Sorry. There's my r. So I'm going to put r and then c over 2 pi. I have no way of knowing what that is, so I just write it exactly like you see it. And that's all there is to literal equations. Let me know if you have any questions. There is both a practice and an application for this particular lesson, so make sure that once you finish your practice, you go back and do your application. You will need to do all of the practice for this particular section. I know we've been letting you do just odds on some of them, but we didn't actually come up with as many practice problems for this, and you'll want to get plenty of practice. All right, good luck, guys.